Number one, we have a box sitting on a table. That box has a mass of 70 kilograms. So the first force that we can't get away from on our free body diagram is the force of gravity or the weight. Now you'll see me write that as F of G, and then you'll see me write that as W. So 70 kilograms, so weight is mass times gravity. So 70 times 9.81 equals a weight of, your paper says 80. Do what? Okay. Second. All right. I'm getting 686.7, and that would be a Newton. Now, right this minute, we're not worried about significant figures. We want to get to the point. What is the point? Find the force normal. Case number one, important. Is this on a level surface? Yes. So, force normal equals the weight. So force normal equals the weight. So force normal is 686.7 newtons. Period. Done. Of course, you can report the correct number of significant figures.
Then it would be 676. Are you confused? Why are you measuring weight in newtons?
Okay, good. Weight is a force, and the SI unit would be a newton. That would be the unit there. Number two. There you go. Number two. That's a good point. Why isn't it just 70? 70 is the mass, not the force. Okay? Number two, determine the force normal on a box that has an upward force of 6 newtons acting on it from a rope that's pulling. So we have a box sitting on a table. Number one force we can't get away from that acts on that box. Weight. Weight's pulling down. The other force is the force normal, which is the table pushing up. There's a third force, according to this scenario, which is a rope pulling at 6 newtons going up. So there's another force, and I'll just draw it to the side so that way our arrows are not on top of each other, and it is 6 newtons. Okay? Now, we already said in our scenario, what happens to the force normal when you're pulling up on the rope? It's going to go down. By how much? In this case, it's going to go down by 6 newtons. So what does the force normal equal to start with? The weight. Okay? So, force normal is going to equal the weight minus any pull that's acting on it. You see that? Any pull that's acting on it. So what's the force normal? 15 kilograms times 9.81 minus 6 newtons. Lordy, I hope y'all see why I brought that block of wood out here with that orange, yellow rope on it, whatever color rope it is. Okay, so 15 times 9.81, 141.15 minus 6 newtons that we're pulling up. 15 times, that looked really high anyway, 15 times 10, yeah, 150, yeah. 15 times 9.81, clear that. 15 times 9.81 equals, I get 147.15 minus the 6 newtons gives us that answer that we just got, 141.15 newtons. And we can go back over and label force normal is 141.5. The weight of the object is 147.15. All of these forces add together to equal 0 because the box is not moving. Y'all see the cases I tried to demonstrate. Number 3, draw the force normal and the force applied due to gravity. If a 70 kilogram box is sitting on an incline of 35, we have an incline, 35 degrees. There's a box sitting on it. Getting a smidgen ahead of myself right here. Very important. What's the number one force you can't get away from? Gravity, or the weight of an object. Which way does it act? It always acts straight down. The weight of the object. Now, we tried to model this and hope we made this clear. Some of the weight, when you're on an angle, some of the weight does what? Pulls it down the ramp. Okay? So some of the weight pulls it down the ramp. So, now this force has a special name that we hadn't done yet. This is called force parallel. Force parallel. Those two lines are parallel lines, right? Force parallel. The force from gravity pulling down and incline. Okay? Now there's another force from gravity. What's that other force from gravity doing? Yeah, it's called the force perpendicular. It is a force that acts perpendicular to the surface and goes straight down. And it is called force perpendicular. And we draw that little T like that for perpendicular. So we can come over here and write a note. Force perpendicular. The force from gravity pulling into the surface of object. So there's a force pulling it into the surface of the object, called force perpendicular. We got perfect amount of time to finish this. What's the force normal? It's equal and opposite to one of these forces. So force perpendicular is going down. There's a force going up called force normal. And they are equal but opposite. So in this case, force normal equals force perpendicular. Here's what I hope you saw from the little 20 minutes of me saying stuff. What happens when you put something on an angle? The contact between the object, the table, say it again. When you put something at an angle, the contact between the table and the box decreases. Eventually, if that table's straight up and down, there is no contact force between it and the box. It just goes straight down. Okay? How would we get this? Well, if we know this angle, then we know this angle. What leg is this? Adjacent or opposite? That's adjacent to this, so the trig function cosine. So force perpendicular is the cosine of the angle times the hypotenuse. The hypotenuse is what? The weight. Or mass times gravity. So we will finish this. So the cosine of 35 times 70, which is our mass, times 9.81. Force perpendicular or force normal equals, tell me again. 562.5. 562.5. Okay. Now number 4 combines a couple concepts. We need to end right here. Like, please, Lord, are you with me? Can you calculate force normal on a flat surface? When we push objects together, when we pull objects, and then finally on an angle. Yes, your question, David.